Yeah, thank you for joining me here. This is an unused site after 2 years, but I'm glad to be back at the conference again. And talk about my work mainly, which is what I do. I'm the author of a library called Byte Buddy, and I work a lot with code generation. And what I try to do here today is to give you a short introduction into Java agents, which is something few people in the Java ecosystem work with, but which is something that basically everybody comes in contact with. A lot of tooling in the Java space uses Java agents, let's say JVisual, VM, and so forth, but also all the monitoring agents. If you look at Datadog, APM, Instana, Elastic APM, but also security agents, they all implement this API I want to show you. So, and even though if you might never come across it as a developer, I think it's good to understand how these tools are working and that they are actually not so scary to develop. Yes, and since we only have a half hour, I should have changed the title to something less expensive, so we really just have time for an introduction. But if you are very interested in this topic, I recommend you to just look up the title on YouTube or Vimeo. I always try to angle it differently, so to cover a large range of topics in this field, but and not to repeat myself too much and not bore everybody. So, but for those of you who never have seen an agent, I first need to show you what it is. And you all have seen a public static void main method, I assume, which is the first thing that people come in contact with when they work with Java. What many people have never seen, on the other hand, is a so-called public static void pre-main method. The JVM knows 3 entry points to its system. The most common one is the main method, which needs to be present for a valid Java program. The less known one is a pre-main method, which, as the name suggests, runs prior to the main method. So you can create a jar file instead of having an attribute in the manifest in there that says main class, main entry. You put in pre-main class, and then you refer to the class that defines the pre-main method. You can have multiple of those. So you can have many, many agents, infinitively many in theory. And you can basically use them to prepare your system for something. And you might have seen that if you have specified an agent on the command line. Even less known than the pre-main method is the so-called agent main method. It is possible in the Java space to have a jar file attached to the JVM even after the JVM has already started to run. So you can say this JVM that has been running for a year, I want to add some additional code to it. And I'm going to show you how this works. But in the principle of it, again, you create a jar, just like a public static void main jar, with a manifest entry that says agent class, and here's the class name, and it's supposed to define this agent main method. And those are the 3 entry points a JVM defines. And I don't go into detail on this, but you can also write this in C code using JVMTI. But for the most, I think Java code is a better approach. Right. Again, you can have multiple agent main methods, but you only have one attached thread. So if you don't clear this thread at some point, you cannot have multiple ones. But normally, it's just a short attachment, and an agent spawns its own threads once it's done. So how does a Java agent look like? As suggested, you say public static void pre-main, and then you take a single argument, not an array of strings, but a single string, which is the thing you can prepend on the command line. So you write Java minus CP for class path, and then you specify the jars you want to have there. And then you also write minus Java agent, and then specify where your agent lives. And then you provide the argument, which will be here my agent, and then the agent will print hello from my agent. It's of course not useful, but that's the purpose of Hello World programs, that they're not useful but easy to understand, and this will work, right? So you can copy paste this code, add a manifest, and create this my agent jar with the pre-main class, and have it run. And from that, you can already think how this can be useful. Let's say you want to set up some configuration, some system properties, for example, or initialize a database context that's used by the application, and you could do this using this agent. You can decouple the agent from the actual application. And that's the nice thing about it. You can, of course, add this to a regular program, but you can build 2 separate jars, update them separately, and not have them intertwined in any way. You have 2 really separate artifacts. And of course, that makes most sense if the artifacts come from different vendors, from your APM tooling, for example, and you write your app yourself, of course. But of course, you can write this yourself as well. So this is the agent main, the pre-main. The agent main looks just like that, only that you don't specify it on the command line. The agent main, as I said before, is injected after the fact. So once you have run your application, the tooling you use will discover your JVM process, find out its process ID, and then say, this process ID I want to mess with, so I want to add some code to it, right? And then it's going to change after, and completely independent. And the advantage, of course, is that you don't have to change your deployment setup or anything. So an APM tooling I worked with, for example, in Stana, basically you install just a host application on the physical machine, and it would scan all of your containers, your Kubernetes clusters, and then find Java processes in there and just inject itself there. So basically a configuration-less approach. Then this can be very convenient. And of course, JVisualVM is probably the most known example. If you use JVisualVM to monitor a running Java process, then JVisualVM will inject a Java agent that way into the Java process you want to see. And then it will sample stack traces in there and get all the info out that you want to know about. It's not magic in any way. It's just a Java agent. You can implement this yourself, basically, in plain Java. The API to do so is added in its own module since Java 9. Before that, it's hidden away in a jar that's shipped with the JDK that's called tools.jar. But today it's a module of its own that can be loaded. There's an API called virtual machine, has a static method that's called attach, and you just provide the PID, so the process ID to it. Then you find it and you say load agent, and that's it. It's that easy. Right? This is the important thing to understand, those two Java processes are separate. You start a Java process to attach to a third Java process. And then you can basically go in there and load your jar in there. So this small program just needs to be separate and know what program to attach to the actual application that you want to monitor. So let's say JVisualVM is a Java process, you spin it up, and JVisualN uses this code then to go into the Java processes you want to monitor. Okay, so far so good. The interesting part, however, is not just having the capability of running some code. You could do this by yourself if you wanted to mingle two Java processes. You could just combine them right before you start, right? The most interesting and attractive part about a Java agent is that you can have a second optional argument in the pre-main and in the agent main method. And this is the instrumentation instance, which you see here. And the instrumentation instance is basically an interface into low-level functionality of the JVM. And this is a standard functionality, so every Java virtual machine that wants to be standard compliant needs to implement it. And I say that because that means all JVMs but Android, and all JVMs in a way but Graal. Graal native image, if you want to use that, doesn't really support Java agents, and Android has never supported Java agents, which is one of the reasons that a lot of tooling doesn't work the same way there, and also like code generation libraries generally. That's why Hibernate and all these frameworks struggle a bit around there. And yeah, what does this instrumentation instance offer you? It gives you some low-level things, like you can measure the size of an actual object, the physical size in memory, for example, and so forth. But that's not the most interesting part. The most interesting part that most people use is the so-called class file transformer API. So what's a class file transformer? A class file transformer allows you to take a class file that is loaded and modify it before it is loaded. And think of a class file as basically just the compilation unit of your .java file. So let's say you wrote your own HTTP client, then a Java agent can receive this HTTP client and modify it in order to, for example, measure how much time it takes to make an HTTP call. So if you ever wondered how these APM tools know what your application is doing and how long time it takes, it is because they will discover, for example, your usage of Apache HTTP client. And when Apache HTTP client is loaded, it will go through this transformer, and then the APM tooling will rewrite the bytecode of these methods that do the HTTP calls to inject their own logic and to extract this information. And this is, again, also what JVisualVM does with some classes, and this is how all the tooling in the Java space works. And it could be so easy because a class file is nothing but a byte array, and you just return a changed byte array. And of course, the housekeeping is more difficult than just changing a few bytes. You need to produce correct bytes, and this is what libraries like mine do. But of course, admittedly, also other libraries. But I'm not going to talk about them. The maintainers have to do their own talks about it. But basically, this byte array manipulation is the job of a tool in the Java space. So first you have to, of course, decide if you want to transform a class. Most classes you don't care about. But then once you discover something you're interested in, like as I mentioned, an APM tool, an HTTP client, a JDBC driver that does a database call, everything that really does I/O normally, or that does threading, will then be modified in the means of the agent's purpose. Again, with a dynamic agent, typically you attach to a JVM only after the JVM has started. And you do this to not interfere with startup, especially like if you're in finance or so, you need your pods to come up quickly. But you can still, after these applications already started running, go in there, and as with the pre-main agent, modify classes, but you then have to say that classes that were already loaded need to be retransformed. So it's even possible to change a class file in a running application after it already has been started to be used. And typically, again, this is used by APM tooling and security tooling to basically find all the important parts of a program and to change them. So for example, modify your JDBC driver to detect injection, for example, for SQL injection. But not do this basically as part of the program startup, but do it right after the program started up, so you have a short window of vulnerability then, but right after you're in there. Yes, and again, this works completely without any change of the person developing the Java program. You can just inject it afterwards, right? And typically that's what it's used. I know also a few use cases, for example, in the performance space, if you use some messaging libraries for I/O, they typically write very particular bytecode to force the JVM to go into JIT compilation patterns that they know about and that they want to enforce. So they don't add logging anywhere, because even if the logging is no-op, it pushes the method over a certain bytecode count, which affects the performance considerations of the JVM. So what these libraries then do for logging is to write agents that you can attach afterwards if something goes wrong, and only if something goes wrong, because then you change the application, ruin the performance in a way, but you still get the logging without having the logging code in the framework. So that's also a way of doing it. You can go as far as even writing bug fixes. I've done this also for clients when there's applications that aren't very sensibly developed, that you cannot turn them off, like old banking systems typically, and basically an outage would be a disaster. So, but you still have to bug fix something, then you can basically write an agent to patch the change in there without restarting the JVM. So there's a lot of use cases here, but typically it's tooling. Yep. So how is this even possible? I already mentioned it. If you write a Java class, it looks like this. Then you compile it into a .class file. And the .class file is nothing but a byte array. So if you return bar, then there will be bar encoded in UTF-8 somewhere in this class file, right? And basically, if you want to change it to return something else, you find this bar value in the class file and you change it to be something else. You flip the bytes, best case just one letter in UTF-8, then you just have to change the byte. If you want to produce something longer, you have to find the offset, change some of the housekeeping values, and basically lengthen the array. But normally, you don't want to do this. Normally, you use a library. And another use case, I already mentioned APM. I'm maintaining a library called Mockito with another guy, which I met for the first time now on Sunday, actually. He lives in London. Mockito also uses Java agents in the inline mock maker, which is now recommended for Java 17 and up, where the old mock maker unfortunately doesn't work anymore because of internal API sealing done by OpenJDK. So Mockito can also just attach an agent to the Java process itself, and then find a class that you want to mock, and then just change the method code to reflect this mocking logic. So basically, we just have a registry in Mockito now, saying this instance is a mock. Then we change the method bar. If this instance is a mock, do nothing, else do what you would normally do. So even in libraries like Mockito that do more complicated things, Java agents can be used for benefit. And also, of course, using Byte Buddy there, as I'm the maintainer. And yeah, so you will come across Java agents anywhere. That's, again, why I think it's important to understand them. So much about what agents are and what agents do. I'm halfway through, so that's actually not so bad. An example of how you can do more complex instrumentations using Byte Buddy now. And again, Byte Buddy is my library. It's open source, and it's free open source, so you can download it from Maven Central. In Byte Buddy, what you do basically is you find just, you have an API called Agent Builder. You create an Agent Builder, and then you just tell this Agent Builder what types you're interested in intercepting. So you write .type and has supertype, and then named my target user type. So, and hopefully you understand what this is doing. So basically you're telling Byte Buddy to instrument all classes that are inheriting from a type named my target user type. And then you transform them and you say, any method of this type I want to intercept, and I want to do a method call on these methods and invoke the method of printstream, println, and on the field system class out, which is system out println, of course. And you say hello world, and then once you're done with that, you want to do the super method call, meaning you're invoking the original method that is implemented in my target user type, right? And you can type a word for it, but if you copy this code into IDE or in a text file, compile it, bundle it with the manifest entry, and then of course you need to create a class named my target user type and subclass it somewhere. Then you will have written your own first Java agent, which of course does nothing useful again, as Hello World examples do. But you will have seen how easy it is to write these toolings, and now you can think for yourself how APM and all these agents that you are running in your production systems work. They don't print hello world, they just report to some backend that this method was called. So you can build a call graph and do some tracing and measure time, how long things took, and so forth. So that's all the magic. So the instrumentation is not really the difficult part anymore today. The difficult part is, of course, to find out what classes to instrument and how to instrument them. But it can very much be done by anybody without any prior experience necessarily. Yeah, I have color here, which I normally should step through. To spin it into a more realistic direction, to write an agent that is more in the means of a production-ready agent, you wouldn't normally use this very detailed DSL to specify all the steps of what you want to do. It's normally more convenient and more reliable to use a mechanism in Byte Buddy which is called advice. And I'm nitpicking here, of course, features out of Byte Buddy, but anybody who writes a Java agent in this time and age, most of these people are using Byte Buddy, and almost all of these people are using advice templates. And advice templates basically let you allow Java instrumentations in plain Java. And that was the goal also with developing the Byte Buddy APIs for that, or this is what I thought about when this is what I wanted to create, and after many, many years I arrived there. And advice templates basically just say, I want to intercept again my target user type, but just read this org Apache HTTP client, for example, all supertypes of that, and then I want to transform all the methods of this HTTP client with my hello world advice first, and I take this on any method that is defined on it. And the advice is basically just a Java class with one or two static methods, and these methods are annotated with either on method enter or on method exit. And as you hopefully can infer from that, you will have these methods called on the entering of this method that you instrument or on the exiting of the method. And again, we will print hello world because it's so easy to get from hello world to reporting to a backend, of course. But the mechanism is easily demonstrated. What Byte Buddy will do then, it will take your user type with the method foo and copy-paste this template code in the beginning of the method. And it really copy-pastes the bytecode, so don't set a breakpoint in your on method enter, because it won't be triggered. It will copy-paste the code, and this is done for performance reasons, but also for class loader visibility reasons. You basically just write a Java class that Byte Buddy then will use as an inspiration for how your instrumentation should be done, right? And you can also use this with disable class format changes and retransformation. Then Byte Buddy will already work as an agent main method, which you can inject on a later time, right? So again, you have your very performance-sensitive application. You don't want to instrument anything or add any bytecodes, but suddenly something goes wrong, things go slow. You think you have no chance of debugging this because you don't have logging available. But of course, you can now just write an agent, inject it, and still get the information out that you want. I mentioned that there's exit instrumentation as well. If you just copy the enter code. That's easy. Copying the exit code is a bit more difficult, because what Byte Buddy will need to do for you is that it copies the return value into a temporary variable, store it there, then copy in the exit code, and then do the return, because otherwise, of course, the method won't work. But this is done transparently for you. And Byte Buddy has a good 1.4 billion downloads today, and a lot of agents use it. So this is working so reliably that I haven't had an error in a couple of years. There's a lot of tricky issues in there, but it will work for all JVM languages. So it works for Java, Scala, because it operates on the bytecode level. Don't be distracted by the Java here. And and thanks to the bytecode format, which is very coherent and very stable, I hope and think it will work for many, many Java versions to come. So basically, you can write any complex Java code, and Byte Buddy can inline it. Of course, what you still lack here is the ability to interact with the instrumented method, but also that is possible by annotating parameters and adding them to the instrumentation methods in the first place. So for example, if you have an instrumented method that has an argument, and you want to know what the argument is, let's say again, now you're writing your APM tooling and you want to intercept your reactive framework, and then you need to know what the callback is, for example, or where the callback is aiming for. And then you want to get hold of this, so you just annotate advice argument 0, then you will get the argument at offset 0, speaking the first argument. And then you can print system out print well. The Byte Buddy inliner will basically match these two up, and it's a template, as I mentioned before. You never really read the annotated argument. You read the argument that you annotated. And this also works in a writing manner, and this looks like very weird Java code. So you write an on method enter twice, where you have an argument where you assign a value now. So you say the value should be the same value plus bar. So now I write this code. It's nonsensical. Your IDE will tell you this is bad code and does nothing useful. But you have to ignore this, because Byte Buddy will take this non-useful code and put it in as useful code. And that's what you can do. I won't go through all the annotations. This is just an overview of the most important ones, but they grow in the numbers, and you can even write your own annotations. So you can basically interact with anything. You can even override the this instance, so you can change the identity of a method, stuff that's not allowed in Java. You can override the return value of a method, which is important if you, for example, want to instrument reactive frameworks, because you return the callback plus your own callback wrapped around. You can communicate values from enter advice to exit advice, and you can do a lot of things, like you can repeat methods, so jump back up to the beginning of the method from the exit advice. So you, for example, if you want to write a resilience framework where you'd retry a failed method call, and so forth. And it's just annotating. Some people don't like it, but it works very well in this use case. I have 7 minutes left, so yeah, I'll go through some limitations. I won't do class loaders much, but just to understand, I already mentioned it. Advice is nothing but a template. So if you have fields in your templates or have private methods in your templates, that won't work, because the code is copy-pasted, then the copy-pasted code won't be able to call a private method back from your advice code. It won't either be able to access the field from your advice code necessarily, so don't do that. It really needs to be the code that you write. Byte Buddy has a feature where you can circumvent this, and actually Elastic APM has an agent written that uses invoke dynamic with the same mechanism. And we wrote a blog post about how you can write a very ambitious agent if you really want to, but if that's out, yeah, I can refer you to that. So it's possible, but not with the simple approach. There's a lot down the rabbit hole here from, of course, but since we only have 30 minutes, not much rabbit hole to fill in here. The normal approach is that if you want to have information in your advice, then you can bind it via your own annotation, and then basically when you register the advice, you say my constant value should be that and that, and then Byte Buddy will map it for you. That's the right way to do it. It feels a bit alien in the beginning, but it's really not that difficult once you have the hang of it. Yeah, and also the JVM, in theory, Byte Buddy could copy over these private methods too, but the JVM is going in the direction where this is not really desired. So I'm not trying to fight the OpenJDK people and rather follow the direction that they indicate we're going to, and yeah, not trying to add features that I have to unroll in the end again. Just quickly, Byte Buddy also has a way of in-method code substitution. Let's say you have a thread local runname here and you want to replace that with something else. Then Byte Buddy has something that's called member substitution, which is similar to advice, where you can say, I want to take the method println, and I want to stub it on all methods named foo of the user type. What Byte Buddy will do then, it will just remove this code for you. So this is also something you can do if you don't want to add code at the beginning and the end of the method, but do something in the middle. Normally, you don't want to do things in the middle because methods are stable API. Typically, you find yourself methods that are stable API. Once you mess with the code inside, then every minor update to the code will break your agent to some degree. And that's what a lot of old APM toolings did. They basically found code somewhere in there, and then suddenly you have APM tools that need 500 employees to just keep the Java instrumentations up to date. And then, of course, the price range of these tools also rises with the complexity of the implementation. So normally, yeah, this is the approach you don't want to do. And I guess that's also why there's still so much movement in the APM space. Like the early adopters had very complex approaches to it, and the young companies, they come in and do new tooling that is available for just like teams with 4 or 5 people. Yep, I have 4 minutes, so I'll just skip over the class loading section entirely, which was very enthusiastic of me to even include here. I thought about it when I went. It's like the 45-minute talk, actually. And rather do some miscellaneous. Yeah, so self-attachment is, like, fortunately not as easy as I suggested with Mockito. I already showed you that you can attach, like, find your own processing PID and then just attach to it. But since Java 9, the JVM doesn't allow it anymore. Java team doesn't want that to happen. So they forbid it explicitly in the code. But the easy workaround is to just run the instrumentation in a new JVM. So you, JVM, spin up a new JVM that runs the instrumentation code to attach back to the process that started it. Nothing the OpenJDK team can do about this, so that's why I added it as a feature in Byte Buddy 2. You just do that, and it will work in Java 9. This is a side project of Byte Buddy, my library, called Byte Buddy Agent, which offers convenience for exactly that. Can also attach an external agent, so if you want to play around with this feature, I highly recommend you to do this, because it is aware of the fact that IBM's J9 uses a different namespace for the attachment API for some reason, so it can distinguish between what JVM you're running. Also, I re-implemented the entire attachment mechanism using JNI. I even implemented it for Solaris, so if you run Solaris, Byte Buddy can do it. Solaris native OpenJDK can't. And yeah, so basically it's all wrapped, the entire complexity of this. I did it once and never want to do it again. So you can piggyback on that as well. Yeah, this one I also skip over, because then we might have time for a few questions. But one last thing with agents, and that's again important for you to know, because if you write a program, and the garbage collection, especially, I already mentioned JIT compilation can be affected, but that's a very niche optimization. But garbage collection works like that: you have tenured object and you have young generation object, and then your garbage collection shows a certain pattern. If you add tooling, like in APM tooling, AppDynamics, Datadog, Elastic APM, Instana, then these toolings will have their own objects, and these objects will have their own lifecycle. And what often happens if you add agents compared to the normal run of the application is that you mature objects that normally would be young generation into the tenured generation. And your garbage collection might change drastically from running with an agent and without an agent. So it's like the last thing I'll give you in a way. When you have tooling like this in your production service, maybe have an environment where you test performance-heavy code also with the agent, because it will change the GC behavior, and you might need to fine-tune a lot around it. I have 1 minute left, so this is my last slide. Thank you so much for coming. My name is Rafael. You can find me on Twitter, and I'm open for DMs there, so if you have questions around this, just find me there. And of course, find Byte Buddy and my other open source stuff out there. Thank you so much. And yeah, I have 1 minute for questions, so maybe one question we can do. Yes? So if you can attach an agent, you need to run a process under the same user as the JVM you're attaching to, or a user that has access to that user. So if you're already there, you're already screwed. So on this level, there's no security left because you already have control of starting processes with the same user identity. So worst case, you can just switch out the memory entirely anyways of the process that the JVM started for you. Yep. One more question, maybe? Yes?
What happens when you detach the agent? So is there anything that I want to run an agent?
Basically just closes the socket. Time's up, it says. So thank you so much, and yeah, see you around.